Hey everyone, in today's video, I'll start a new topic, that is electrochemistry. So what do you mean by the term electrochemistry? Okay, so it is nothing but branch of chemistry which deals with interconversion of chemical energy into electrical energy. So by utilizing chemical energy, we can produce electrical energy. So here electrical energy can be converted into chemical energy, otherwise chemical energy can be converted into electrical energy. Okay, so in electrochemistry, mainly we will get the term conductors. So let us see some basic terms here. Okay, so electrical conductors or conductors, the substance which allow electricity to pass through them, are called as conductors or electrical conductors. So best examples you can give is iron rod, copper plate. If you take a copper plate and you are passing electricity, they easily pass the electricity through it. Even you can take water as a good conductor. Even human body is the best example for electrical conductor. So there are two main types of electrical conductors. One is metallic conductors, another one is electrolytic conductors. So metallic conductors are the conductors which conducts electricity due to the flow of electrons or passage of electrons. So all metals comes under metallic conductors. If you are taking copper plate, gold plate, iron plate, all these are good metals. We know metals are good conductors of heat and electricity because all metals have a high electropositive nature. They lose electrons easily and they form positive ions. So the lost electrons in the plate readily responsible for the flow of electricity. So here the electricity is passed through due to the flow of electrons. So because of the electrons movement, the electricity is taking place inside any copper plate, gold plate or silver plate. Okay, so electrolytic conductors, these are the conductors in which flow of electricity is due to the flow of ions. So here we are not getting electrons, but we are getting the ions term. Ions means, we know, for example, NaCl. If I take an NaCl good electrolyte, it can break into Na plus and Cl minus. Okay, so under molten state, otherwise when you are adding to water, what happens? This NaCl can break into Na plus and Cl minus. These ions readily responsible for the flow of electricity. We know ions attracts electrons easily. Okay, so due to that, the flow of electricity taking place. Okay, so these are the basic terms in electrochemistry. Now let us see about Arrhenius theory of electrolytic dissociation. So in order to explain the behavior of electrolytes, Arrhenius proposed this theory in 1887. Okay, so what are the main postulates of this theory? For example, when we take an electrolyte, when we dissolve that electrolyte in water, it gets splits into different ions. Okay, they are called as cations and anions. Already we know cation means a positively charged ion, anion means a negatively charged ion. For example, AB is electrolyte. You are adding to water, it gets splits up into A plus and B minus. A plus is cation, B minus is anion. Okay, so the ions which are formed have a tendency to reunite. So whatever ions are forming in this solution, they have a tendency to reunite and form again an unionized electrolyte. Okay, so because of this, there is an equilibrium between this unionized electrolyte and these ions. Such equilibrium is called dynamic equilibrium. Okay, so we can see AB electrolyte is giving rise to A plus and B minus. Again, this A plus B minus combines together to form undissociated electrolyte. You can see there is this reaction, both forward and backward reaction is taking place. This is a reversible process. So whatever electrolyte is dissociated, it has a capacity to reunite and form the unionized electrolyte. So next postulate is some electrolytes ionize completely when dissolved in water. So when you are adding to water, some electrolytes breaks completely. Such electrolytes are called as strong electrolytes. For a best example, I can give you HCl. HCl is hydrochloric acid. When you are adding to water, it dissociates into H plus and Cl minus completely. When you are adding NaCl, it gets dissociates into Na plus and Cl minus. When you are adding NaOH, this is base, it gets dissociates into Na plus and OH minus, which is a strong base. HCl is a strong acid and NaOH is strong base. Okay, even NaCl is strong salt here. When you're adding to water, they undergo complete dissociation. There are some electrolyte which dissociates up to some extent. They won't dissociate completely. When you're adding to water, it gets dissociates to some percentage. For example, acetic acid, when you're adding to water, it gets dissociates up to 5%. It won't get dissociates completely. Such electrolytes are called weak electrolyte. Best examples I can give you: CH3COOH, acetic acid, and NH4OH, ammonium hydroxide. Okay, ammonium hydroxide is base. Now let us see some more postulates. Total fraction of molecules of electrolyte which undergoing dissociation is nothing but degree of ionization. Okay, so the formula for degree of ionization is number of molecules of electrolyte which splits into ions by total number of molecules of electrolyte. So when you are adding electrolyte to water, what happens? Some electrolytes get splits up, some electrolytes cannot split up. Okay, so what happens? The total number of particles of electrolyte which are undergoing splitting by the total number of molecules of electrolyte is called degree of ionization. This degree of ionization increases with the dilution. So when you are increasing the solvent or when you are adding more water, what happens? The ions, a process of this degree of ionization increases. That means ionization increases means number of ions increases. So when number of ions increases, what happens? Conductance process also increases. So on electrolysis, when you are introducing electrodes in this electrolytic cell, what happens? The positive ions migrates towards cathode. Positive ions migrates towards cathode. Negative ions migrates towards anode. Okay, so positive ions are called as cations, negative ions are called as anions. Okay, so a charge carried by the total charge carried by the positive ions is equal to the total charge carried by the negative ions. In order to maintain the neutrality, the positive charge and negative charge should be equal in any electrolyte. And next, properties of electrolyte is due to the properties of its ions. So for example, HCl is there. This HCl, when you are adding to water, it dissociates and gives H plus and Cl minus ions. So because of this H plus, it is getting acidic property. In the same way, when you are taking NaOH and you are adding that NaOH to water, what happens? It dissociates into Na plus and OH minus. So NaOH producing OH minus ions, hence that is called as base. So any property of electrolyte is due to the properties of its ions produced when you are adding to water or any solvent. Okay, so these are the postulates of Arrhenius theory. So let us see the limitations now. Let us see the limitations of Arrhenius theory. So according to Arrhenius theory, electrolytes remains unionized and won't conduct electricity in their solid state. But when you are adding to water, it undergoes ionization and conducts electricity. But according to X-ray studies, there is a proof that electrolytes conduct electricity in their molten state. Okay, so Arrhenius theory fails to explain the role of water in this process. And it also fails to explain acidic and basic character of substances in solvents other than water. That means what? When you are dissolving substances in water, they produce H plus ions, OH minus ions. Basing on that, we are deciding acidic or basic nature. But when we are adding such substance in alcohol or liquid ammonia, what is their nature? It is not explained by Arrhenius theory. And it also fails to explain our acidic or basic character of certain substances like CO2, SO2. These are non-metallic oxides which are acidic in nature. And these are metallic oxides which are basic in nature. But it does not explain acidic or basic nature of certain oxides. So these are the limitations. And this is completely about Arrhenius theory and its limitations. Thank you so much for watching.